Okay, this constructed response from 2016, I think is really just a group of four pretty straightforward, simple problems, starting with simplifying a square root of 120. First of all, simplifying a square root is different than estimating. Okay? Estimating a square root is kind of like approximating a square root, and if you were just to kind of go on most calculators and type in the square root of 120, you're going to get what, 10 point something? But that's not what we want here. They are asking specifically for you to simplify the square root of 120. I'm going to cover two different methods. The first method is made famous by our very own Mr. Birchanowski. So if you've ever learned from him, what he does is he takes 120 and starts breaking it down into all of the prime factors. So breaking it down as small as we can go, keep breaking it down. Like, for example, what times what is 120? Well, I'm going to start with 10 and 12, even though it doesn't matter how you start. You could have picked, 40 and 3 or 2 and 60. Doesn't matter. But you keep breaking down these factors until you can't break them down anymore, really. And so once you get down to, say, 5, you stop at 5, you stop at 2. 12 can still be broken down into 6 and 2. For example, again, I could have said 3 and 4, but 6 and 2 is fine, and then the 6 can keep getting broken down into a 3 times a 2, and that's where we're going to stop because we've broken it down all the way it can go. And at this point, you now look for pairs of factors. For example, let me just get a different color, I guess. We have a pair of 2's. And when you're doing this Birchanowski method, if you have a pair of 2's, then you bring a 2 out of the square root. But any singles, and I think maybe Mr. Birch would say something like anyone with no friends or anything, any single factors would have to stay under the square root. So we would have a single factor of a 5 that stays under the square root, a single factor of 3, and a single factor of 2. And all of those would stay under the square root, and they would multiply together. 5 times 3 times 2 is 30. So that's one way to do a simplify square root problem. And now I'm going to do a different method, which I find myself doing as a preference. And that is going to just involve breaking down 120, or rather the square root of 120, just breaking it down one time, okay? But you have to break it down in a very specific manner. I can't just break it into any 2 factors. I want to break it up into a square root that I can actually do cleanly. In other words, a perfect square. And the perfect squares that you have to be aware of, at least a certain first number of them. 4 is a perfect square, 9, 16, 25, 36, and that goes on and on. And so I want to break up the square root of 120 just one time and just make sure that one of those factors that I break it up into, I can actually take a perfect square root of. But here's a very important detail if you're doing it this method. you can't just find any perfect square in 120. You have to find the largest one possible. Let me say that again because it's really important. You have to find the largest perfect square possible. And actually, in this case, it's the square root of 4. It's actually not a very big square root, but that is actually the largest perfect square you can break off of 120. Not square root of 9, not 16. And what would be the other factor? So 4 times what is 120? Or the square root of 4 times the square root of what would equal the square root of 120? Pretty much the same thing. And there we go. And so since I broke it up perfectly, since I broke it up into a couple square roots where I could actually do one of them, I'm going to actually do it. So the idea, and what is the square root of 4? That's just 2. And I can't do the square root of 30, so that just remains the square root of 30. So I guess the whole idea with simplifying the square root is at least I did some square rooting. At least I was able to take the square root of something. I took the square root of 4, and that just became a 2. So either way, you get a final answer of 2 root 30, or 2 times the square root of 30. Part B is very, very simple. They just want you to simplify b to the 3rd power times b to the 4th power. I guess I'm going to give sort of a, thorough review and just kind of talk about, well, if we had this situation with exponents, that would be a different story. Or if I had this situation with exponents where I had b to the 3rd over b to the 4th, that'd be another different story. In this situation, you would subtract the powers as a shortcut. In this situation, you would multiply the powers as a shortcut. And in this situation, the one we're working with, you would add the powers as a shortcut. So plain and simple, you add those powers together to simplify, and the final answer is b to the 7th, because 3 plus 4 is 7. Part C, just, again, very straightforward. They want you to arrange all of these in order from least to greatest. And I know it might look a little ugly to some of you or intimidating, but I think the advice I'm going to go with on stuff like this is just convert everything to decimals. Just kind of approximate everything on your handy dandy calculator and change them all to like what they are approximately equal to as a decimal, and that'll make it super easy to put them in order from least to greatest. So, just trying to cut to the chase here. 3 times the square root of 7 excuse me, is about approximately equal to 7.937. The square root of 54 is approximately equal to 7.348. And when you put this in very carefully into your calculator, some calculators would probably have an extra set of parentheses around the 2. Like when you type in the square root function on your calculator, it would like maybe already automatically have a parenthesis there, So you might have not only these parentheses you'd want to type in. So on your calculator you would type in those parentheses for sure, and squaring that whole bubble, but you'd probably also have parentheses right in there. Probably the same thing here. You want to, just in case, you want to include those parentheses when you type into your calculator, and you're probably going to have a more inner set of parentheses that you actually have typed in or showing on your calculator screen. Anyway, once they're in decimals, decimals, it's a whole lot easier to see that root 54 is the least, followed by 3 times the square root of 7, followed by, well, I can hardly tell what that was now, 2, well, there was that one, so 2 root 2 squared, I think that was, and the square root of 5 all cubed. Okay? That's part C. So changing to decimals, very effective. So part D tries to get a little more complex or advanced, I guess, or scary looking, but nope, not that scary. When you read the directions, you see that this value of D needs to be satisfying this compound inequality. And again, there was another video where I mentioned this, how when you see this, it means that your D values, like any value of D, needs to be in between whatever this is and whatever this is. And you know what? It could also equal that, because it's less than or equal to, less than or equal to. But an inequality like this means that your D values could be in between that and that. Well, it's going to be a real smart business to go to your calculator and approximate the square root of 0.8 and approximate the square root of 0.9 and get those two values. So ultimately, you know, again, you should have read this and tried this already before watching the video. Ultimately, you're going to be trying to do what? You're going to be trying to put all of these in least to greatest order. So how are we going to figure out which one's the least, which one's the greatest, what order they go in? It's best to actually have a number plugged in for D, and so we're just going to have to pick based on this interval, and I say let's use 0.90 or just 0.9. Makes sense, right? You know, pick a guinea pig value that qualifies, and now we can really see which one's least and greatest and stuff like that. So, and again, I'm going to want to point something out. Just I don't want to go too fast, and I want to point out some good stuff. When you plug into your calculator, make sure to use parentheses and make sure to type it in correctly, I guess. But your calculator can do a lot of the heavy lifting on this problem. So if there's anything else I want to say about, so this is, I kind of wrote this out how it would sort of look on your calculator, at least the ones I have in my classroom, most of them. So square root, it would automatically start that left parenthesis, 0.9 squared. And look, I guess something I will point out is you're taking the square root of the entire 0.9 squared, so make sure you put your right parenthesis after the squaring. That should make sense. Very similar here when you're plugging in 0.9 here, and that's the little TP button or power button or caret button in order to raise 0.9 to the 3. Notice where the parentheses are in order to do this correctly, and that your calculator is going to say that. When you plug it in there, your calculator is going to say that, and the other two here shouldn't be as tricky, I think. And once again, you want to see what they all are as decimals, so you can much easier put these in order from least to greatest. So let's see if I can do this. What do you think? What would be the least? I say D squared times the square root of D, followed by the square root of D to the third, square root of all of that, followed by the square root of D squared, and the largest one in this case for these types of D values should have been that.